Hello everyone. Section 3.5, Derivatives of Trigonometric Functions. The first two pages show you why the derivative of the sine of x is what it is, and why the derivative of cosine x is what it is. You don't need to memorize these. This is just for people who are interested in where do these things come from. You do have to memorize the derivative of sine of x is cosine of x, and you have to memorize that the derivative of cosine of x is negative sine of x. That's something that you're going to have to know. All right, example 1. We're going to take the derivative of x squared minus sine of x. This is just a power rule and a difference rule. So we're going to do dy dx dx of x squared minus sine of x. So I'm just taking the derivative of the left and the derivative of the right. Derivative of the right becomes the derivative of x squared, which is 2x, minus derivative of sine of x is cosine of x. And that is dy dx for example 1. Example 2. Find y prime if y is equal to sine of x over x. Now, I could make this an x to the negative 1 and do product rule, but I want to practice the quotient rule because later on, when we get to example 4 and another one even further down, quotient rule is really going to be the only rule that's going to apply. So let's get some practice with the quotient rule. So y prime equals, so the quotient rule is derivative of the top times the bottom minus derivative of the bottom times the top all over the denominator squared. So derivative of the top, derivative of sine of x is cosine of x times the bottom. I'm going to write that in front so that it doesn't get confusing. Minus derivative of the bottom is 1 times the top. So I'm actually going to write the 1 in just so that you see it. Times the top, which is sine of x, over the denominator squared. And the rest is just cleaning it up. X cosine of x minus sine of x over x squared. We find f prime of x squared sine of x. This is a product rule and a power rule because we have x squared is being multiplied times the sine of x. So we have a product rule here. F prime of x equals, so product rule, derivative of the first times the second plus derivative of the second times the first. Derivative of the first is 2x times the second sine of x plus derivative of the second is cosine x times the first, and I'm going to write it out in front so it doesn't get confusing. And that is example 3. Example 4 is where we have to use quotient rule. We don't have a choice. Okay, so again, quotient rule, derivative of the top times the bottom minus derivative of the bottom times the top all over the denominator squared. So dy dx equals derivative of the top, derivative of sine x is cosine x, times the bottom, 1 plus cosine x, minus derivative of the bottom. Well, derivative of the bottom, derivative of 1 is 0. Derivative of cosine x is negative sine of x. Times the top, which is sine of x. All over the bottom squared. 1 plus cosine x squared. Now, I'm going to do a little bit of the multiplying here and distributing and see if there's anything that we can clean up. So if I distribute the cosine of x, I get cosine x plus cosine squared x, negative negative becomes plus sine squared x, all over 1 plus cosine x squared. If you remember back to your trig and pre-calc days, cosine squared plus sine squared is 1. So the numerator becomes 1 plus cosine x over denominator, 1 plus cosine x squared, which means this numerator cancels with one of the 1 plus cosine x's in the denominator, giving us a final answer of 1 over 1 plus cosine x. And that's example 4. Now, after example 4, we have a list of other derivatives that you have to memorize. Okay? Derivative of tangent of x is sine squared of x. Derivative of cotangent of x is negative cosecant squared of x. So on and so forth. Derivative of secant of x is secant x tan of x. And derivative of cosecant of x is negative cosecant x tangent of x. And I know they look strange, but you're just going to have to memorize what those are and be able to use them. Example 5. We're going to find y prime if y equals x tangent of x. This is a product rule. We have x times the tangent of x. So y prime equals derivative of the first. Derivative of x is 1. Again, just so that you see it, I'm going to write the 1 times the second tangent of x plus derivative of the second. Well, let's go back to our list. Derivative of tangent of x is secant squared of x. So derivative of tangent of x, derivative of the second, is secant squared of x times the first. And I'm going to write the first up in front so it doesn't get confusing. Okay, and the rest is just writing it up to clean it up. Tan x plus x secant squared x. 6, it looks like we should use quotient rule, and we could, but because I'm going to be changing this square root of x into an x raised to the 1/2 power anyways, I'm just going to rewrite the whole thing so it becomes product rule, not quotient rule. And they're still very similar. So f prime, let me rewrite this, equals x to the negative 1/2 power. When I move it from the denominator to the numerator, it changes the exponent from positive to negative. Secant of x. Okay, so now we're going to do product rule. F prime of x equals derivative of the first, negative 1/2, bring the exponent down, x raised to, subtract 1 from negative 1/2, we have negative 3/2. So derivative of the first times the second, plus derivative of the second. Now let's take a look. Secant of x, let's take a look what that one is. Derivative of secant x is secant x tangent x. So derivative of the second is secant x tangent x times the first, which I'm going to write out in front, x to negative 1/2 power. Teacher or your trig and pre-calc teacher, they may want you to clean this up, but the truth is in calculus, we're happy with your answer as is because you've done the calculus part. You took the derivative. If there's some really simple algebra that you can do, like we can factor out this secant of x, we can factor out an x to the negative 1/2 power, we could probably try to make them positive exponents, maybe bring back the radicals, but the truth is it's not really worth it for us to do that in an algebra, in a calculus class. Okay, we're focusing on the calculus. Example 7. We're going to try and find the second derivative evaluated at pi over 4. Let's first find the first derivative, then find the second derivative, and then we're going to evaluate that second derivative at pi over 4. So the first derivative, y prime of x equals derivative of secant of x. We just did that. Derivative of secant of x up here was secant x tan x. So derivative of secant x is secant x tangent x. Okay. Second derivative is going to involve product rule because we have secant x times the tangent of x. That's product. So we're going to do product rule. So second derivative, y double prime of x equals derivative of the first. We know what the derivative of secant x is. We've just done it. Secant x tangent x times the second, which happens to be tangent of x. So again, derivative of secant of x is secant x tan x. This tan x carries down. Plus derivative of the second, derivative of tangent. I believe we've seen this recently too. Where do we see? We saw that just right up here. Derivative of tangent of x is secant squared of x. So derivative of the second is secant squared of x times the first. Well, the first is secant of x times secant of x. Okay. Clean this up just a little bit. Secant x tangent squared x plus secant cubed of x. And that's what y double prime is equal to. Y double prime of x. What we want to do now is evaluate this at pi over 4. And this involves our unit circle values. Y double prime pi over 4 equals secant pi over 4 tangent squared pi over 4, start putting these in parentheses, plus secant cubed pi over 4. So secant is the reciprocal of cosine. If you remember your unit circle, pi over 4, that's 45 degrees in the first quadrant. The coordinates at pi over 4 are square root 2 over 2, comma square root 2 over 2. Sine is the y value, cosine is the x value. So secant's the reciprocal of the x value. Secant is the reciprocal of square root 2 over 2. So the reciprocal of square root 2 over 2 is square root 2. Times tangent of pi over 4. Tangent is y over cosine, y over x, or sine over cosine. Y is square root 2 over 2, x is square root 2 over 2. Square root 2 over 2 over square root 2 over 2 is 1. 1 squared. Plus secant of pi over 4. We just found that out. Square root 2. Square root 2. Oops, I'm getting ahead of myself. Square root 2 cubed. So now we have square root 2 plus, this is square root of 8 or 2 square root 2 in simplest radical form. And 2 cubed is 8. Square root of that is 2 square root 2, which gives us a final answer of 3 square root 2. It's the answer to example 7. All we have here now is some IXL for you to practice and bookwork for you to do. Thank you very much. Bye.